Hello, I'm Mrs. Jacobson, and today we're going to work on some composition of functions. It's from Module 10 and 11. So the first one is just introduction, and what the composition does is you're plugging one function into another one. So we're plugging t into s. We're going 4 to t to s. So if we have s of x equals 3x plus 3, and it was negative 3, yeah, and then negative 3x minus 1. We want to find s of t of 4. Well, you're just plugging in and finding t of 4 first. And t of 4, plugging in here, negative 3 times 4 minus 1 is a negative 13. So this is negative 13, so we want to find s of a negative 13. And this is a positive 39 plus 3 is 42. So you're just taking the value, plugging it into this one, and taking that answer and plugging it into the next one. Let's try one more. That's the same one. Here, we'll just plug a value in here. Let's find t of s of 1. So it's saying first find s of 1. Negative 3 times 1 plus 3. Negative 3 plus 3 is 0. So we take that answer and replace the s of 1, which is negative 3 times 0 minus 1, or a negative 1. So that's the introduction. When we go to the basic, they just have a little bit harder equations, but it's the same thing. Quotient, composition, here it is. There we go. Notice it's written a little bit differently, but it means the same thing. So this could have been written so this little circle means composition, and that just means that. Go plug 1 into s, get that answer, plug it into t. So in this case we have q of x equal to x squared plus 3, and r of x equal to the square root of x plus 2. So if we want to find the composition r of q of 2, that means r of q of 2. So we're plugging 2 into q, so we're plugging it in here. Q of 2 is 2 squared plus 3, or 7. So we take that and we want to find r of 7, because q of 2 is 7. And plug that in. 7 plus 2 is the square root of 9, which is 3. Other way, the composition q of r of 2. So they want q of r of 2. So we need to find r of 2. R of 2, square root of 2 plus 2, which is the square root of 4, which ends up 2. So we're finding the q of 2. 2 squared plus 3 is 7. That's all that's to those. Domain's a little bit more difficult. Composition, domain, and range. So we're looking at the domain and range. Looking at the first one, 1, 3, 6, 7, 8, 9. 1, 3, 6, 7, 8, 9. 3, 6, 7, 8, 9. Let me write these down real quick. 0, 4, 6, 7. 4, 5, 6. And 1 and 9. Okay. Okay. G. Okay. So the first thing I want to do is look in the middle and see where they overlap, because we're finding f of g. But we need to see where they overlap. Notice the 4 and the 6. So this one's out, this is out, and this is out. Now we want to see where 4 and 6 go, because like when you're working backwards, whatever you get has to be here, because that has to fit into this one, which then goes backwards. So first, find your middle. What overlaps? Now look at the f function and see 4 goes to 9, and 6 also goes to 9. So that locks this out. And this is the range. Now to find the domain, we have 4 and 6. Well, which ones come from 4 and 6? Well, 4 is 7. And 6 is 6 and 9. Let's just double check. So we look over here. 4 has one arrow. We wanted the 4, and it's 7. And then we wanted 6, and it has arrows from 6 and 9. So these are the domain. Six, 7, and 9. Let's try one more. Okay. I just want to make sure it wasn't the same one. I always write them 2, 3, 4, 5, 2, 3, 4, 5, 7, and 8. This is G domain. And then 0, 1, 3, 0, 1, 3, 6, 8, G range. Then we have 1, 2, 3, 5, 8, 9. 1, 2, 3, 5, 8, 9. And this is F's domain. And the range is 4 and 9. So first we find out where the overlaps in the middle. We have a 1, 3, 6 doesn't 8. So only those three. We want to see where these go in here. 1 goes to 9. 3 goes to 9. 8 goes to 9. So this is our range. Then we go back and see which ones would give us these. So if we look here, 1 comes from the 3. 3 also has 1 arrow from the 7. And 8 comes from the 5. So these are the domain. 3, 5, and 7. One more. Zero, 3, 4, 6, 7, and 9. Domain of G. 0, 2, 6, 8. Range of G. 0, 2, 5, 7, 8. F's domain. F range. 2, 3, and 9. So the first thing we do is see where the middle overlaps. We have this one, and 8. So the rest drop out. Then you want to see where these go. This will give us our range. 0, looking here, goes to 2. 2 also goes to 2. And what was the last one? 8. 8 also goes to 2. So we have one range, it's 2. Now you see which one of these lead to 0, 2, and 8. So if we look at 0, 4, so 4 gives us 0. We look at 2, that comes from the 3. And what's the last one? 8. 8 comes from 9. So our domain is 3, 4, and 9. One more thing. Composition of two functions advanced. Composition, that's the first one. Okay, so this one, instead of putting a number, you're putting the whole function inside of it. So we have for the real valued function g of x equals x squared plus 5, and f of x equals the square root of x plus 6. We want to find g of h of x. G of f, whoops, was it f or h? H. We know h of x is this. So we're just taking this and plugging it in here. Plug it in. And then we can square this because you do want to simplify them. The square root squared is just x plus 6 plus 5, or x plus 11. And I forgot to put it on. So you took the one function and plugged it into the other one. So in place of h of x, I put the square root of x plus 6. Then I took this and plugged it into this one. So just like before, we're taking one and plugging it into the other, except we don't have a number. When you square this, you get x plus 6 plus 5, which is 11. Now it wants us to find the domain. So when you're plugging it in, yeah, they do want, I wanted to make sure they wanted it simplified here. They do. You have to simplify. And they're showing how they plugged it in. Now when you're finding the domain, you don't just look at the end of the function, because we know x plus 11, no fractions, no square roots, it's all real numbers. But you have to remember when we plugged in here, there were values that were omitted. So what you want to do is find the domain of this and then see, once you simplify, if there's any more that needs to be taken out. So if we look at the x plus 6, we know that x plus 6 needs to be greater than or equal to 0, which means x has to be greater than or equal to a negative 6. Now this one's not going to omit any more because it's a polynomial. This is all real numbers. So this is our domain. And they want it in domain interval notation. So it would be negative 6 to infinity. And you're including the negative 6 because a square root can have 0. Unless it's in the denominator. Let's try another one. Okay, so we have g of x equals this, and h of x equals x minus 5. We're finding g of h of x. So that means that h of x is this. We're plugging this in. And we get x minus 5, because that's what h of x is. And we take that and plug it into the other function. So in place of x, I'm putting x minus 5. Distribute the 3. X. So this would be our answer for g of h of x. They also want the domain. Now the value, the one we plugged in was this. The domain for this is all real numbers. So we didn't have to omit anything here. Now we go to our answer and see. Well, we have a square root, so we know what is under the square root needs to be greater than or equal to 0. Bring the 12 over and divide by 3. X has to be greater than or equal to a negative 4. Negative 4 to infinity. Let's try one more. So we have g of x equals x minus 2 over x plus 1. F of x, or h, I want to do f, h, 2x minus 3. And they want g of h of x. We're going to do both on this one so you can kind of see the difference, hopefully. G of h of x. So we're plugging in h of x. Just 2x minus 3. Now we're taking this and plugging it into x. So we have 2x minus 3 minus 2 on top. Then on the bottom, in place of x, we're putting 2x minus 3 plus 1. 2x minus 5 over 2x minus 2. So that would be the answer. Now when you're finding the domain, the one you're plugging in you look at first. Well, this one is all real numbers, so nothing's omitted yet. But then when I get down here, I know that 2x minus 2 cannot equal 0, because that would give me 0 in the denominator. Adding the 2 and then divide by the 2, x cannot equal 1. So our domain would be negative infinity to 1 and 1 to infinity. If we go the other way, h of g of x, we're plugging in the first one, x minus 2 over x plus 1, which then is 2 times x minus 2 over x plus 1 minus 3. Which doesn't change it too much. We multiply. You can multiply the 2 across the top, 2x minus 4 over x plus 1. But really, there's nothing else you could do. Now, when you're checking the domain, first we would look at this one, because that's the one we're plugging in. And we know that x plus 1 cannot equal 0. Bring the 1 over, x cannot equal, was it a plus 1? Negative 1. Oh, that's right, it was different here. X cannot equal negative 1. When we come down here, we still have that fraction, but it's the same one. So it's negative infinity to negative 1, negative 1 to infinity. That's it. Trying to think of one that would be something different. This one. So if we find g of f of x, that means we're starting with f of x and plugging it into this one. So that would be the square root of x that's getting plugged in. Plugging it into here, it would be 1 over the square root of x. That would be our answer. Now, this is the one we plugged in. We know that x has to be greater than or equal to 0, because you cannot take the square root of a negative number. When we look down here, the square root's in the denominator. So not only does it have to be greater than or equal to 0, it can't equal 0, so it becomes x greater than 0. So there's a case where you have to omit something more than what you already had. So this would go from 0 to infinity. But always start with the one you're plugging in, see what's omitted, and then see if you need to omit more when you get your final answer.